Ever wondered why your Wi-Fi slows down when too many devices are connected? Or why wired networks feel faster but limit your mobility? In today's world, where staying connected is everything, understanding the pros and cons of wired versus wireless networks is crucial. In this video, I'll break down the key differences, show you how wireless networks handle multiple devices, and reveal why wired networks still dominate in reliability. Whether you're a tech enthusiast or a networking newbie, this guide will help you choose the right setup for your needs. Ready to optimize your connection? Let's dive in. In a wired network, two devices that want to communicate with each other must be connected by a cable. What is obvious? This cable can contain strands of metal or optical fiber. The data that passes through is delimited by the physical properties of this cable. This is called QoS, the IEEE 802.3 standard, better known as Ethernet. Wired connections are very efficient, which allows for good communication. To ensure this reliability, the standard must, of course, be respected. That is, the size of the wire strands, the number of twists, as well as the maximum length not to be exceeded according to the 802.3 standard. The data flows between the two heads of the cable, whether it's fiber optics or strands of metal. These electrical signals, which are used to transport data, therefore travel from one end to the other. In this type of configuration, the two devices that are connected on the same network cable have a direct communication path. They can exchange data and even transmit data simultaneously. So even if cable networks are very reliable, there are some shortcomings. For example, when a device is connected by a cable, it is difficult for it to move. That is to say, he can't go very far. In addition, in order for a device to connect to a wired network, it must be equipped with a connector that is compatible with the end of the cable. For example, RJ45 or a fiber optic connector. And as devices become smaller and more mobile, it's often not practical to connect them to a wire. That's where the wireless network comes in. As the name suggests, a wireless network removes the need to be attached to a wire or cable. Nowadays, mobility is becoming more and more important. Users should be able to move around at will while remaining connected to the network. In addition, with this technology, a single user can connect to the network with several different wireless devices. Data flows in a free space without the constraints and protections of a cable. As data flows freely through the air, there are many variables that can affect this data and its delivery. To minimize these variables, network admins should focus on two important things. Wireless devices must comply with the IE82 ONS on INL11 standard, and wireless coverage should be available only where users should be using it. So, for the NACC, keep in mind that the review is more about a functional vision of wireless technology. For anything more advanced, such as RF characteristics or antenna performance, it is rather reserved for CCNP exams. We will now talk about the different topologies. Wireless communication takes place in an open space through the use of radio frequency signals, which are found with the RF symbols. The theory of these RF signals can seem complex and will be discussed later in the course. For now, we're going to start with a simple example, that of two laptops. In this diagram, let's just assume that PCA is transmitting RF signals to PCB. As can be seen, the transmitter can contact the receiver at any time, as long as both devices are set to the same frequency or channel and use the same process to transport data between them. Here, we have a one-way communication, which is not necessarily practical. To take full advantage of wireless communication, data must travel in both directions as shown in this diagram. With two-way communication, the two PCs can communicate simultaneously. But to avoid interference, since both PCs use the same channel, the PCs will have to manage some latency between them. The more the number of devices increases, plus there will be interference. For example, this diagram shows us 3 devices tuned to the same channel and what could happen if one or all of the PCs were transmitting at the same time. This type of problem may remind you of a traditional local network, i.e., not switched, where several hosts shared the same bandwidth. To use Wi-Fi effectively, all hosts must operate in half-duplex mode to avoid bumping into other transmissions that are already in progress. As with Ethernet in half-duplex, this means that no host will be able to transmit and receive at the same time. Well, a wireless LAN is very similar. Because multiple hosts can share the same channel, they also share the same air zone, or channel. Therefore, to keep everything clean, only one device needs to transmit. To comply with this requirement, the devices are based on the POSIX 1802.11 standard, which allows you to determine if the channel is free and available before transmitting any data. This means that all WLANs in IEEE 82.11 are always half-duplex, because transmissions between stations use the same frequency or channel. Only one station can transmit at a time. Otherwise, collisions occur. To have full duplex Wi-Fi, the transmission of a station will have to be on one frequency, while it receives on a different frequency, just like full duplex Ethernet networks. So even if it is certainly possible to do full duplex over Wi-Fi, the 802.11 standard does not allow this type of operation. There are still some methods that allow several devices to transmit on the same channel and at the same time, but this is not on the CCNA's program.